Welcome to the Next Human. My name's Arav, and today I'm here with Dr. Mike Miroshnikov, senior scientist and NMR uh, spectroscopist at Pfizer. Thank you so much for being here today, Doctor.
Thanks. I'm honored to be able to speak with you, and thank you for having me on the show.
And just to be clear, you don't think I missed anything in that intro, did you?
Um, no, that's pretty much correct. I could definitely tell you a little bit more as we go on.
Awesome. Oh yeah, so first, the thing I kind of like to ask is all about you. Like, what would you say your life story is kind of? How did you basically get to where you are today? And what was kind of your journey?
Yeah, so starting from I guess an earlier age, my parents they moved to the United States from Ukraine
Mm.
when I was very little, and I guess a lot of my journey has really kind of been rooted in my Ukrainian identity. My grandfather was an educator in Ukraine. He was one of the smartest people that I ever knew. When we were little, he used to just tell me a whole bunch of tidbits and factoids about everything, from cars to engineering to nature. And I guess like that would kind of be my first exposure to science, right?
Uh,
As I got older, I found that I have a good talent for math and science. But I never really wanted to go into the medical field. It kind of just didn't appeal to it. Maybe I'm a little bit squeamish. Who knows?
mm.
Maybe the personal aspect wasn't good for me. But I always just really like to investigate things. I like to put together puzzles. And that's just kind of how my mind works. So eventually I decided to pursue my PhD. I got my PhD in 2020, and I was actually working on something completely different from what I do now. I was working on battery materials, so kind of finding biologically and natural derived compounds to serve as reusable, recyclable batteries, right? Things that are more environmentally friendly compared to batteries that are based on metal alloys that are polluting to the environment. So I really consider myself a material scientist. I was kind of doing a lot of work characterizing battery materials with a variety of spectroscopic techniques. And ironically, that is kind of what led me into pharmaceuticals.
Mm.
Because I graduated, I got my PhD in 2020. It was kind of in the midst of the pandemic. And I was really looking for, I was really being open-minded as far as my career opportunities go. And I ended up going into pharma because they needed somebody who was doing NMR spectroscopy. So it's a commonly used technique in organic chemistry. And, I'm
Mm.
not sure your familiarity, but it's a powerful technique to elucidate the structures of organic compounds. And they needed somebody like that in the pharmaceutical industry. I worked for one company in Connecticut for a year, and then eventually I got an offer for Pfizer, and I couldn't refuse. So now that's where I am.
Awesome. I guess this is kind of like a more personal question, but uh, do you like enjoy the like organic batteries and stuff more, or like what you're doing now, like spectroscopy?
It's actually a good question. I asked myself that a lot. I really loved the application of batteries. I think, batteries are the future as far as renewable energy, going away from fossil fuels. That was like an amazing application, for me at least.
Mhm.
And I thought that that's really what I would be doing for the rest of my life. But sometimes, we kind of go through some twists and turns. And I eventually, what I like the most about being a scientist is, I think, as I mentioned to you, the investigational aspect of it. So the way I look at it now is that I'm just investigating something else, and we're doing it for another really useful application. We are kind of doing investigations and developing drugs that save patients' lives and save the world, I guess, in some ways. As you can tell from the example of the pandemic. So
Hmm.
it's a thrill in a completely different way. And I think being at Pfizer really spurred my interest in my current field even more, because you get to work with some of the most brilliant people in the world. I really believe in some of not only the smartest but some of the best humans. I think best people personally that I've ever worked with,
Hmm.
and interacting with them kind of keeps the excitement burning in me. You get to kind of really see behind the scenes of all the drugs, that amazing drugs that we've developed um, over the past couple of years, and see the story of those headlines in the news unfold, and how the cogs in the wheel work. So I would say that they're two different forms of passion, but I wouldn't be I wouldn't rather be anywhere else in the world right now. So,
Oh, that's great. Yeah, I mean, like I haven't interviewed like a lot of people, but from the ones I have, I think I've noticed a pretty like common theme where it's, someone can start out doing something like this in their life, and then later on they can just like totally transition, and it's not like the things that they learned doing that one thing is just completely different from this. I think it's just like kind of like all paths lead to one. Everything is kind of learning is like a process that it doesn't really matter what field you're doing it in. It's something that just can happen wherever. And like I mean growth also comes along with that. But on the topic of like organic materials, I just wanted to ask you a little bit about the work you were doing for your PhD. I just want to ask, like, how did you guys figure out? I read a little bit about it, but like, like if I'm not mistaken, like the dye molecule in henna has some like properties for that make sodium ion batteries run. That's better is kind of like the vibe I was getting. I wasn't quite sure, but like I just wanted to ask, how did you guys like figure that out and like that whole experience?
well, I mean, the short answer is we didn't figure it out.
Mm.
Our work is based on the backs of many pioneers, and
Mhm.
science is kind of iterative, right? Like, you could point to something and say that person invented it, but in most cases, that's not actually the case, right? They usually somebody builds off the backs, of the work of somebody else, and then somebody
Mhm.
else adds something new to it, and then somebody else adds something new to it. And that's a little bit how science works. And sometimes somebody makes a big breakthrough and they become famous for it, and people are quick to point to
Mhm.
that person is responsible for this or invented it. And most of the time, it's not actually so simple as that. So I think there's many scientists. Off the top of my head, I can't possibly name them all that have worked on organic battery materials. But where we came in is we wanted to see if we could take it a step further, because with organic batteries, um, you're still kind of talking about something that's in its infancy, right? But we wanted to use molecules that are derived from nature. So we were working on molecules that are coming from this class of quinones. And there's a lot of quinones that can be synthetically derived, or you can synthesize them. But you're a little bit adding to the problem, because when you do an organic synthesis, you're adding more chemicals into the mix, potentially more harmful chemicals in the mix that you're using for the synthesis. So when we're talking about our idea of a renewable, recyclable battery that's better for the environment compared to metals, we're really trying to maximize that that concept. So we were looking for molecules that were derived from nature, and the the interesting thing about organic molecules is they have this common motif, is that they have this electronegative oxygen species that can bind metals.
Mhm.
And you could find a lot of molecules like that in nature. And it so happens that, many dyes that the people commonly use and don't even think about having any sort of utility have these properties. So one of those molecules was the, henna compound. Um, and even there, we weren't really the first to think of, henna as potentially a battery material, right?
Mhm.
One of the big problems with organic compounds as batteries is, you need an electrolyte for a battery. And electrolytes are usually organic solvents. And what happens when you put an organic molecule into an organic solvent? It just dissolves, right? So you
Mhm.
don't want your battery to just dissolve, then it wouldn't be such a great battery. So then we were like thinking about ways in which we can modify the molecule, so
Mhm.
to have less soluble properties and still bind the metal. Um, and one of the things we did is we did a kind of a simple, very non-toxic reaction to sort of take, one unit of this molecule and combine them to create like a 4-unit, binding compound in which it could then bind 4 sodium atoms and then become less soluble. So that's kind of where we conceptualized this tetrachus lawstone, or so we called it, compound.
Mhm.
And it worked pretty well. And we saw that it like really improved the performance of lithium ion and sodium ion batteries that were created from this compound. And in comparison to just the monomer unit, our tetramer unit had much better performance and had better stability. So yeah, so that kind of just goes along my point that it's a little bit of an iterative process. We always try to find ways to improve upon our own designs and designs that other people might have conceptualized. So yeah.
Awesome. And you said like organic batteries are kind of like in their infancy right now, but I mean obviously like the work you guys did and the work that people are doing now is obviously gonna like push that along. But like what would you say kind of the ultimate goal of like organic materials like sciences? Like
So like I said, so a lot of the challenges right now are based around the solubility.
mm,
And it's a little bit of a push-pull. So, for example, you could, I told you that we made kind of this tetramer of our compound. So you could take it one step further. You could make a polymer, right? So then you could have, thousands of units all binding sodium. But there's a trade-off, right? Because when you polymerize something, so not all the parts of the organic molecule are um, accepting sodium ions and are conductive of electricity. There's
mm,
a lot of carbonaceous material that does not conduct electricity, right? And so when you polymerize it, you not only increase the amounts of the parts of the compound that accept ions and are conductive, you also increase the parts that are non-conductive.
mm,
And so that has implications for the performance of the battery as well. So it's gonna, take other smart people
mm,
to kind of continue to work on these things. And there's an issue of how much we can scale it up. Um, there's kind of finding compatible electrolytes, because one electrolyte does not fit all types of battery chemistries.
mm.
Um, so these are all things you have to take into consideration, but I'm hoping, either myself in the future or somebody else can definitely bring these things into reality. Because if we're talking about, the future of electric vehicles, all these technologies that are supposed to be, green technologies,
Mm.
um, we really need to, you know, mean what we say and do what we mean, because, you're not being very green if you're, needing to um, mine precious metals, metals that are potentially toxic, create factories that are still giving a lot of emissions, and those factories are the ones that are needing to manufacture your lithium ion batteries, right? So um, it's not a be all end all solution. There's trade-offs to everything that we do. So we need to make the technology better, and I think organic materials can be one step in the right direction.
Hmm. And I mean, I think I'm sensing a pretty common theme here in like everything you're saying about sustainability. And I guess it's pretty fair to assume that sustainability is a pretty big point of like action for you. And I guess yeah, that's just kind of like a general question. Like to you, what does sustainability mean? And I guess what does it look like?
Yeah, I think people throw around that word sustainability a lot. I think that as far as sustainability goes, it's not just creating environmentally, friendly, materials and items.
Mhm.
It goes for sustainable practices as well, right? I think that need to try to minimize, harmful chemicals wherever you can. We're doing that a lot, with Pfizer as well. Like we have, a net zero initiative where we are, planning to be carbon neutral and
Oh,
emissions
wow.
neutral by 2040. I'm helping a lot with that initiative as well. So I think, as far as sustainability is, like we have to develop practices
Mhm.
that for the long-term future are not, just putting a band-aid on a situation. Electric cars, for example, they make people feel good now, but what are some of the long-term implications? Will we always have the materials to mine? Same with pharmaceuticals. You can have a great drug, but we want to make treatments that will not just make our patients feel good in the moment, or put a band-aid on their issue and have a disease come back. We want to create treatments that are going to solve the problem and eradicate diseases. So we have to have sustainable practices as far as our use of harmful chemicals that are bad for the environment. We have to have long lasting materials that solve problems in the world, and we also have to have treatments that are for the long term benefit of our patients. So all those things are sustainable. So I think when we look at sustainability, it's not about the short term outcome, it's about the long term outcome, and it's about our long term practices as well.
Mhm. Yeah, that's great. I think um so you kind of like define it as more of like a full frontal assault rather than like just kind of yeah, like, as you said, like putting a band-aid on like the problem. And
Yeah. And
um
that starts with habits and good habits and practices. So I
mhm,
really put the focus on having consistent practices for the benefit of society.
mhm. So you said like Pfizer's initiative to be carbon neutral by 2040, and you said you're helping with that, and I was just that's I mean that one for one that's really cool. But I guess I want to ask like what's I guess your guys' plan for that? Because that's pretty I'm fair to say I think it's a pretty lofty goal.
Yeah, I mean, we're looking at it from both a grassroots perspective and a high level perspective. We're taking a look at our laboratory practices. We're actively right now, having a lot of meetings, remediating practices that could be considered, unsustainable.
Mhm,
Getting rid of wasteful and inefficient solvent uses where we can, recycling items where we can, as far as not just it's I'll say that with a grain of salt, because for safety reasons we can't just
yeah, of
recycle everything. If
course.
things are contaminated with chemicals, if gloves are contaminated with chemicals, we're not
Mhm,
going to reuse them because that's going to be unsafe for somebody. But when we can, we're reusing items. We're trying to minimize the use of electricity, as far as a lot of our instruments, our scientific instruments, use a lot of power. So we're trying to minimize the power usage of our instruments.
Mm.
Um, we're trying to minimize travel for meetings. So yeah, like I said, recycling, travel, energy usage, usages of certain gases we're trying to eliminate. Like, for example, there's a you may or may not know, there's a huge helium shortage right now going on. So a lot of our instruments are, especially for NMR, we're using liquid helium because we need extremely low temperatures for our instruments to run. So to kind of minimize our costs and help with this helium shortage, we're installing helium recycling systems in our labs. So it goes on and on and on. This is ongoing. We're keeping metrics. We're implementing change where we can, as long as it's safe.
Wow, I mean that's awesome. Um, and yeah, I think one thing is that in my mind, what I was thinking when you said originally the carbon neutral thing was I was thinking a lot about like the labs and just I guess the like amount of plastic waste that's kind of generated from labs. And on one hand, it's it's like important, it's essential. And on the other hand, there's a lot of waste being generated. So that's I'm sure one thing you guys must be like really, I mean, I really have a hard time dealing with because yeah, just the nature of it.
Yeah, I mean, it strikes me all the time, right? I'm in the lab all the time, and it always strikes me of how many, how much reusables we use, right? Like, yeah, gloves, syringes, glassware, things like that. And a lot of it just goes in the trash, and a lot of it goes in the trash for a good reason, right? Because,
Mhm.
like I said, you have some, pharmaceutical reagent on your syringe, things that are cause pharmacological effects if somebody were to ingest it, or it would, if it were to be absorbed onto the skin. You can't go reusing that, right?
Mhm.
So but what we can do is maybe think about changing some of those plastics for glass and metals. But again, take that with a grain of salt, because if you replace things with glass, then you have to wash those things, and then you're using a lot of water, and you're using detergents, and so that creates another problem. But yeah, the goal is to find a balance, hopefully, and offset poor practices with better ones.
Yeah, I mean, I think overall, like that's such a like an amazing goal. I feel like sustainability is one of those things where long term wise, there really is no loser. I guess in like short term, it'll probably like cost money and like resources, but I guess when you like look at the long term impact overall, it's just better for everyone.
Yeah, and we're living in a society where people expect more from the companies that they trust.
Mhm.
At Pfizer, we're a company that kind of really prides itself on having the trust of both our patients and customers everywhere. And
Mhm.
people expect more from those companies, right? They
Mhm.
expect them to be environmentally and socially conscious, and so we want to do right by our patients, and we want to do right by people who put their faith in us. So that's where it comes in. We I think we owe it to people to have this sort of conscientiousness, and put an effort into you know sustainable practices, because maybe it will cost us more in the short term, but in the long term, it'll be beneficial to both our company and the people that we serve.
Yeah, and I think like it's pretty clear you guys are um, putting a lot of effort and consideration into that um, endeavor. And I think that's just awesome. But switching tracks a little bit, I just kind of want to ask you to explain a little bit more about the work you're doing now in spectroscopy. And so you said earlier that what you're doing is basically elucidating the structures of like different compounds and I guess just like how it works and um, what exactly that means is my question.
Yeah, I could touch a little bit on that, and we're not going to get into the deep
Yeah,
scientific theory because I don't want to put your viewers to sleep,
yeah.
what I will say is a lot of times you have synthetic process to
Mhm,
make a drug compound of interest. And our chemists are some of the best in the world, and they could design the best synthetic path in the world.
mhm,
But it's not going to be 100% efficient. Maybe it's 99.9% efficient, right? And so 99.9% of the molecules will collide, and the reaction will go as expected. But 0.1% of the time, maybe the molecules will not, and you're going to get some unexpected side product or impurity.
mhm,
And that cannot go into patients, right? So we need to isolate that impurity. We need to identify it. And before the drug can go to commercial use, we need to purge it from the system. So the identification of those compounds falls to our group. So we use NMR spectroscopy. If you're not familiar, you expose your nuclei in your molecules to a magnetic field.
mhm,
Um, it's it basically then apply a radio frequency pulse, and those molecules then get excited, and when they relax back down to their initial state, you get some sort of signal which can then be translated to detailed structural information. And so from that we can tell detailed connectivity
mhm,
um, about our compounds. And even if there's a slight difference, because, for example, sometimes impurities are very similar in structure to your drug compound, except for maybe one or two bonds and where they're located on the molecule. And by other techniques, you wouldn't be able to even tell the difference from the drug candidate. So our aspect is to be able to tell those slight differences and elucidate that using spectroscopy. And once we have the structure elucidated, we could tell the chemist, okay, well, this is going on, this is what's going on, and then we can kind of work on a path to remediation and also disclose those findings to the FDA.
mhm,
And so another thing that I have going on right now is I'm actually doing a secondment opportunity in working on a completely different field. So like that was kind of early stage drug development. I'm improving my skills and making a foray into late stage drug development.
mhm,
And in that case, we have really innovative technology. So we're kind of moving away from a batch manufacturing process in which you have several steps in the process, and between each step, a person might need to inspect, the product, manipulate it, see what's going on, and that slows down our manufacturing process. So we're moving to a continuous process in which all the steps can be automated and done in one, and that really helps us get our products to the patient much faster, and that's kind of
mhm,
like what we pride ourselves on. So I'm helping develop this continuous manufacturing. We call it PCM&M, or it stands for Portable Continuous Modular and Miniature. So the concept of this is that we can take our manufacturing process, assemble it like Legos, ship it overseas, if we wanted to, so we can move our manufacturing process anywhere we want, and we can facilitate technology transfer. So I'm working a lot with the methods development to kind of at each step of that manufacturing process, take a look at what's being manufactured and make sure that it's up to standard and up to par using, again, spectroscopic methods, a
Mm.
different type of spectroscopy, infrared spectroscopy, and we could tell whether the proportion of our active compound is, correct in accordance to our formulation before it kind of gets out there and goes to the patient. So those are the kind of two areas that I've worked on at Pfizer.
That's sorry, wow, that's like awesome. I don't really know um what else to say. That's like it's super cool. And yeah, I mean, you definitely, just from like hearing you explain it, I feel like you're definitely um having a lot of fun.
Yeah,
And
it can be fun. I think that more, sometimes it could be not so fun
mm,
because it definitely requires a lot of work, a lot of
mm,
understanding, a lot of both understanding of the chemistry, but as well as, the technology.
yeah.
Some of this technology is even, new to me, and nothing that I learned in grad school could have prepared me for this type of
Mm,
responsibility. I think that in grad school, I practiced a lot of chemical and elucidation techniques for materials. But when you go to industry, it's a completely different ball game.
yeah.
It's being applied and used in ways I could have never been could have imagined. And I feel sometimes that I'm kind of head in the woods, and I'm like just a baby relearning things for the first time. So it's kind of a really humbling experience. I would say
Mm.
it's kind of like learning chemistry all over again for the first time. But that's what I love about it. It's no matter how much you think there's always more to learn, and I kind of consider myself a lifelong learner. So
Wow. And I mean, that kind of transitions pretty nicely into like the next question I wanted to ask, which is um kind of, well, if you couldn't be a chemist or couldn't be a researcher and basically doing something other than what you were doing right now, you couldn't, be in a similar field, what is it that you'd want to do?
yeah, that's a really good question. I sometimes think about this a lot. I think that um yeah, I would say that the answer would be a musician.
Mm,
So before I even entered grad school, I was working on, composing some of my own, electronic music and DJing a little bit. And when I tell people that, they're pretty surprised, and I think that it's not surprising to me at all because even people like, you could look into it yourself, but even people like Einstein, Einstein was a very good piano player, and both science and music take a lot of creativity and a lot of
mm,
imagination because certain scientific ideas, it's not the first time I heard it, that somebody would be looking at a painting on the wall, and something about the pattern of the painting would inspire them for how molecules could come together and react.
huh,
So it takes some imagination to do good science, and then you think about innovative things that people have never done before.
mm.
And so in some ways it's an art, and so is music, and you have to be creative to be both a musician and a scientist. So I think definitely a musician.
That's great. You'll have to show me some of your music sometime.
Oh no, I can't. It's too embarrassing. Actually, sometimes I pull out those old files and I listen to them, and I was like,
Mm,
oh, that's actually like pretty good. If I kept going at it, I would have, maybe been decent. But it at the time, I think it takes a lot of time and effort, and also a lot of money in the music software to be able to
yeah.
kind of produce professional things. So I think maybe that's kind of what intimidated me, and also maybe my mom told me you're not doing that.
Uh,
But yeah, I'm happy. I'm happy where I am, and music will still always continue to be a hobby for me, whether I DJ at my friend's party or something like that. So I keep up with it, and I still music is definitely a passion of mine.
what advice would you give to someone who's just entering the world of like research and like biochemistry, but just like is the PhD the right play?
Yeah, so I wouldn't say that I wouldn't give a universal blanket statement as far as whether the PhD is the right play, because as you know, that plenty of biotech CEOs don't have a PhD.
Mhm.
A lot of them are lawyers, entrepreneurs. There's many different ways to start a business and get your ideas out there, and everybody has their own path. For me, a PhD was the right path because I was interested. It was a source of pride and a little bit
Mhm.
of honor for me, and um, I like investigating problems, and I kind of enjoyed developing my own project and my own thesis that I kind of took from start to finish, and have that sort of immortalized as kind of my baby and my project.
Mhm.
But that being said, there's so many ways to do it. You can of course collaborate with people who are scientists. A lot of company dynamics have a chief science officer, and have a CEO that's good at other things. So as long as your skills complement each other, there's a lot of things you could bring to the biotech sector that doesn't necessarily involve being a scientist yourself. That being said, if you do want to get scientific training and you know, go a scientific education path,
Mhm.
the best advice that I could give is pursue something that you're passionate about. Don't worry about whether that is the hot topic right now, or if that's trendy, or as long as you believe in it and you think it has some application,
Mhm.
pursue that, because just like me, your career could change plenty of times.
Uh-huh.
You always have translatable skills. Science is not it's not so compartmentalized that, okay, if you do one subject matter, then you have no other skills to do something else. So you could
Uh-huh.
always pivot, and I think being able to pivot is super important. I think as far as careers in STEM, I see a lot of people and scientists getting discouraged as far as the job search, because these things are kind of set up to intimidate us, right? You see job postings, and people say, we want 8 years of experience in this and this and this, and people say, I'm not even going to try, because
Mhm.
some AI bot is going to filter me out if I don't have these experiences. But that's not the case. I think the number one piece of advice is you always have translatable skills, and what matters the most is some of those soft skills, because even scientists, you get to a company and everybody's really smart, but the people who can really differentiate themselves are people who have other skills as well, people who are charismatic, people who can be leaders, people that you can work with easily, because science is highly team based, so you
Mhm.
have to be somebody that people can work with as well. And I wouldn't be able to get along with my teammates. I think we're all smart, but we need to be compatible as people, and speak to each other and communicate. So your knowledge, your intelligence, that gives you your credibility, but doesn't necessarily develop trust. So that's one thing, having those soft skills, as well as your book smarts, is really important.
Mhm.
And Yeah, like apply for everything that you could be interested in, and then show employers what you have beyond the book smarts, because that's what a lot of employers and companies look for as well. Um, so yeah, that's the best piece of advice. Be ready to pivot if you need to, as far as where your career goes. Be open to opportunities. If somebody presents you an opportunity, and if you're not sure whether you can do it, I would say say yes regardless, because a lot of skills can be learned, on the job. So say yes to opportunities, even if you're not sure you can do them. And yeah, remain flexible.
Well, thanks for the advice, and especially to me because right now I'm just kind of entering the start of the application season and everything. So yeah, thank you for that insight. And just in general, thank you for everything that you've shared today. And I think it's really helped me look at, I guess, just all the topics like sustainability, I mean, spectroscopy. I didn't really even know what exactly that meant. I mean, obviously I knew what it meant. It's just you explained it pretty well, I
Yeah.
think.
Trust me, you're
Um,
not the only one, but hopefully, this interview could help educate more people too,
yeah,
right?
yeah, true. But yes, I mean, thank you so much for being here today. And
Thank thank you. Thank you. It was a great conversation, and really honored that you could have me on the show. And yeah, thank you. Appreciate you, man.
yeah, thank you. I'll let you get to dinner. And don't want to keep you any longer. So yeah, thank you. That's
Thank you, Rob.